The next question of Lead Code Weekly Contest 380 is find beautiful indices in the given array 1.
In this question, we are given with string S, we are given with string A, and we are given with string B. Okay, these are the three strings given. Along with these, we are given an integer k, right? And what are we supposed to do with this? We are supposed to find out the beautiful indices in our string S. Okay. So what is a beautiful index? People might ask. Basically, in our string S, we want to find indices ith index where if you start a substring from S from index I all the way up till I plus a dot length minus 1, this substring should be exactly equal to it, the string A. And there will be some index j where if you take substring of S from index j till j plus b dot length minus 1, then this substring will exactly be equal to b. Right? So I is the indices where if you create a substring of length a dot length, then it will be exactly equal to a. J is the indices where if you create a substring of length b dot length, then it will be exactly equal to b. Right? So once you found out I and j, we actually need to find that do we have a j such that j minus I absolute difference is less than or equal to k. Okay. If j minus I is less than or equal to k, it means that I is a beautiful index. And we should find all the beautiful indices. And we should return a vector or a list of all the beautiful indices in ascending order. Looking at the constraints of the question, it is given that k lies in the range of 1 to 10 power 5. It is also given that your a dot length and your b dot length will be less than or equal to 10. And minimum value of the length of these two strings is 1. Right? It is also given that s dot length will be less than or equal to 10 power 5 and k will be less than or equal to s dot length. And s dot length minimum size is 1. Okay. Along with that, it is also given that string A, string B, and string S will contain lowercase English characters. These are the constraints.
So let's see how we can solve this. Firstly, prerequisites for this is binary search or two pointer. So we can use any of these. So now let's see how we can solve this. Let us consider S as our string. S0, S1, S3, so on till Sn minus. And A is our string that is given. Let it be A0, A1, A2, so on till A. Let's say x minus 1, x is the length, and B is B0, By minus 1. Now, in S, if we know, firstly for a particular index I to satisfy the criteria, it should satisfy two conditions, right? I to I plus length minus 1. This substring should be exactly equal to A. And this substring should be exactly equal to B. And I minus J mod should be less than or equal to K. Right? So now, from these three, firstly, let's focus on the first condition. So let us find out all indices I such that the first condition satisfies. For that, we can do a brute force, right? We can just see, we can just fix I and then search if I till I plus 1, I plus a dot length minus 1 subarray, I mean substring of S, if it is exactly equal to A or B. If that is equal, then that is a possible I which satisfies the first condition. Right? Similarly, we can do a brute force and find out all J's which will satisfy the given condition. Right? As A and B's length can just be 10 in the worst case, we can do a brute force by fixing I and finding out all the I points by searching for A. Similarly, fix every J and search for B from the fixed J and find out how many I's and J's satisfy I satisfying the first condition, J satisfying the second condition. So let's say I's which are satisfying the first condition are I1, I2, I3, so on till
Ix.
X let's say J2, so on till J by X. So let us assume that these indices are in ascending order. So we just arrange these in ascending order. Now, for each I, we need to check if the third condition satisfies or not. Right? That is absolute of I minus j is less than or equal to k or. For that, we can observe one thing. For any fixed I, we have some set of j values. Right? Among this set of j values, closer the j is, better will be the smaller will be the distance. Right? So we'll try finding out the closest j values to I to verify if I satisfy the condition I minus j less than or equal to. Basically, for any I to be beautiful, there should exist at least one j which satisfies the third condition. So that means what we can do is for a fixed I, we can just find out the floor of I in j, whereas the floor of I is the value, the j which is which is just less than or equal to I, right?
Which is greatest integer. Which
The
is
greatest integer, which is less than or equal to I. Similarly, ceil of I in J is the closest integer, which is greater than or equal to I. Right? We can find out the floor of I in J and ceil of I in J. For this, we can do binary search or use a two-pointer to do this, or we can just use a set. Using lower bound or upper bound functions, we can get this. Now we can check if absolute of floor of I in J, if this is less than or equal to K, or I minus floor of, not floor, ceil. Floor is already done. Ceil of I in J, if this is less than or equal to K or N. Because it's useless checking smaller value than floor of I, because that would increase the difference. Right? If floor of I itself isn't giving a better difference, then the smaller one will never give. Similarly, holds for C. If the closest one, which is greater than or equal to I itself, isn't giving the required distance, then for sure the higher value, higher J than that will never give the difference, because difference will keep increasing as we increase J. Increase J from the point ceil of I in J. So if any one of this satisfies, then we can say I is beautiful. Anyone satisfies, then I is beautiful. So, this way we can solve the problem. Just applying a binary search and finding these. Before that, doing a brute force, extracting all the set of indices I which satisfy first condition and all the set of indices J which satisfy second. And for third condition, we can apply binary search, find floor of I in J and ceil of I in J, and check if any one J for a fixed I, is there any one J which satisfies the condition absolute of I minus J is less than or equal to with this. Okay. So if we look at the time complexity of this, assuming we are doing brute force to find out I and J, time complexity would be big of length into A dot length plus into A dot length.
B dot.
Sorry, B dot length plus now in the worst case, I and j values can be till s dot length. Right? So let's write it as s dot length. S dot length into log of s dot length. Assuming we are performing binary search. So getting the C length. And this can be this if we apply 2-pointer, this can be brought down to s dot length. So if we apply 2-pointer, it would be s dot length. Else it would be with binary search or set, it would be s dot length into log of s dot. So this would be the time complexity. And space complexity, we can say it is big O of s dot length, right? In this way. So this is per test case. And this is sufficient enough to passing the given time of 1 second. Assuming 1 second is allowed for this is sufficient enough to pass in 1 second. So this way we can solve it.